Hi, Kiki here, and welcome to another episode of Keep Kids Coding. This week, we are going to start again on cssfun.com, and we are going to play with Thinking Myself. This is one of my favorites. Let's see if you can figure out why. So this is an old Flash game that hasn't been updated since my master's program, but considering that all of it was done in about a term and it was all done by me, I actually think that it went pretty well. So we have a couple of things going on here. We have this side button here that's going to walk us through each of the steps. Although if you just go through clicking the next button and you follow the program along, it will take you through everything. You'll notice the colors are kind of purple, yellow, and blue. This was based off of personal preferences from young girls in the age of about 8 to 12 years old. Also, girls of that age listed fonts like Arial and Times New Roman as their least favorite fonts to look at. Their number one favorite font? Comic Sans. As an artist, I couldn't get myself to use Comic Sans, so we used felt marker instead. I'm going to be your guide as I walk you through these computational thinking lessons. I'm going to show you that it's possible to figure out anything if you're willing to think for yourself. Continue clicking through, and it says you have to look at a problem in a different way. Let's practice looking at a problem that you've never seen. They've probably never seen it unless they've done Thinking Myself before. Now there are no instructions. See if you can figure out what to do. And here's the machine with no instructions. Now, of course, I know how to solve this problem. A fun little fact is that the younger a student is, the quicker they usually solve this. Once you get to be an adult, you put all sorts of preconceived notions in there, and all of a sudden you are no longer able to just learn from the item itself. If you do something correct, you will notice that the start button begins to fill. Now this isn't actually a button, even though people sometimes believe it is at first. This is an indicator from start to finish. Now, as you go through, you'll notice that if you're getting it right, this light will stay green and this bar will continue to rise. But as soon as you do something wrong, the red light goes off and all of your progress gets wiped away. So you'll go through this, and then in the end, once you get it correct, it will go all the way to the top and a face will appear and say, congratulations, you did it. It's very important if you're trying to retain girls that you have that facial approval. Girls like to see happy faces in response to the things they've been doing. So we've built that into this game. Also, there's a little applause button here. And students can click that anytime to give themselves a little bit of audible reassurance. That is there not as any response to anything they've done, but whenever they feel like they need that personal applause to keep them going, it's a button there that they're allowed to click. After you get through that machine, you will get this smiling face and then a little message that says, yay, you did it, you figured it out all on your own. And then you get to proceed to the next lesson. Once there, you get a little overview of what we're about to cover. Computational thinking, it gives you some definition. So the first thing we're going to learn is about decomposition. It tells you what decomposition is, and then it gives you an example of decomposition. So this is multiplication, and it decomposes into addition. So it'll go through, give you a little example, and now it's going to give you a problem that you can decompose on your own. So you have 8 cubes here, and you need to put a sticker on each face of each of these cubes, and it wants to know how many stickers you need. And you need 48 stickers. And then you get to play a game to test the things that you've just learned. So we have this big old pile of numbers here, and we need to sort them out into their appropriate buckets. So any number that has a value of between 1 and 5 goes into that bucket. Any value 6 through 10 will go into this bucket, and any other value will go into this bucket. Now, there is no you're wrong. You can drag this into here, and all that will happen is it will pop back out. And so they get to learn for themselves that that's not working and they need to try again. Now, once everything has been decomposed into its individual buckets, then the individual buckets can be sorted on their own. Next lesson is about patterns, and it's going to show some patterns here and then give a definition, give you the chance to explore your knowledge of patterns. Now you have to figure out what these items have in common. I'm going to pass through here so that I don't give away the answers, and then we're going to play a game. So we want to copy this picture by clicking the squares, and this is a pattern recognition exercise. Some people will be able to look at the triangles inside of these squares and just see where the pattern goes. Other people, it's going to be very difficult for them to actually pick out the pattern. It takes a little bit of practice. If your class has been doing tangrams, this tends to be a little bit easier for your students. Fill these all in, and once you see them, you see them. Okay, time for the next lesson. This is abstraction, which basically means taking the detail out of a problem so you can make a solution work for many things. We're going to abstract some sentences. This is one of my favorite explanations of abstraction. Basically taking out any place that things are different and filling in a blank. You'll see the same stuff in the code.org because it just makes for such a simple explanation of what can be a pretty complicated topic. All right, next. You'll see that there are some things that vary. We turn it into a blank, and now we have an abstracted sentence that works for many different things. If we want to abstract it further, we can create another blank, and then we'll have another area for a parameter that we can pass through. And then wings. There we go. So we're going to use abstraction to play a game with inputs, parameters, and abstraction. So here you go. We have this machine, and we're trying to figure out what makes purple. And we're going to put these things in, and out pops purple. I'm not going to show you the rest. I'm going to let you do this yourself, but the same thing continues. And the next lesson is about algorithms in general. Now, some people call this automation, that fourth step, but algorithms and automation kind of go hand to hand. It's trying to figure out how to take a problem that's complex and has many angles and put it into a logical set of instructions that a computer could follow, or any sort of automated machine. And algorithms are a great way to do that. So this algorithm, we're going to learn about cookie dough, and we're going to talk about almost the difference in speed of an algorithm. So how you can do things simply. We're going to use a cookie recipe as an idea of an algorithm and go through. Notice that there's this loop here. So once you get to 3, you loop through and do 3 several times with each ingredient, and it's going to show you that. And you go through your algorithm. You can continue on to play the last game. Now, you're following an algorithm, and this is going to test your ability to follow that algorithm. Now, you have to click each island as you travel. So it says to start at the blue island, you click the blue island. You move 4 islands east, and then you click. Move 4 islands south, and then you click. 2 islands west, 2 islands north, and 1 island west, 1 island south, and you found the treasure. Ah, right? And that takes you to the end of our lessons. I really enjoyed our lessons. I hope you did too. And until next time, keep kids coding.